Welcome back to episode number 9 of this tutorial series / crash course on ROS2. You can find the series playlist in the description. And let's get started. As for now, in this tutorial series, we have created one publisher in one node and one subscriber in another node. But we can do better than that. We can create one node which is going to contain both a subscriber and a publisher. And in this particular case with the turtle sim, what we are going to do is to create a closed loop system for the turtle. So first of all, let me show you what we are going to do and what topics we are going to use for this closed loop control. Let's run, so ROS2 run turtle sim with turtle sim node. Okay, we have the turtle, and then let's do RQT graph. Okay, so we have just the turtle. Let's actually uncheck dead things and leave topics, so we can see all the topics even if there is no publisher or there is no subscriber. And now what do we want to do? Well, we want to control the turtle sim with a closed loop control. So we want to control actually the turtle in the turtle sim node. What we will need to have, we will need to have actually the pose of the turtle to know where the turtle is. And we will need to send commands to actually this topic, command velocity. So we will create a node somewhere here that's gonna subscribe to the pose and publish to the command velocity. And this node is going to monitor the pose, so receive current position, and send an appropriate command depending on what it has received from the position. Okay, so the loop will be like this, closed loop control like that. And basically what we are going to do in this controller is we are going to say to the turtle, just move forward, and then we are going to define some borders which are not, so not this border and not that border, but a bit before, so that the turtle can actually turn around when it gets closer to the edge of the window, turn around and continue to move, for example like this, and then turn around, continue to move, etc. So that the turtle can continuously move forward and turn around when it gets closer to any of the edges of the window. Alright, so now that we know what we want to do, let's actually kill the node and kill RQT graph. Okay, and let's now create a new file. So we are going to go to our workspace source folder, my robot controller. We have already 3 Python files. Let's create another one, touch. Let's do turtle controller.py, and then, so let's actually put this here, chmod plus x with turtle controller. Okay, now let's go back to our source folder and let's do code dot to start Visual Studio Code in the source folder of our workspace. So we don't need this anymore. Okay, and now let's edit the turtle controller.py. So first things first, let's initialize the node and the file. So that we've already seen several times. So interpreter with Python 3, and then let's import rclpy. Let's import, so from rclpy.node import node. We are going to create a main function with args none, so that's gonna be the same all the time. All right, rclpy.init with args equal args, then rclpy.shutdown. Okay, I'm not gonna create if name is equal to main, so I'm not gonna do like my first node here, because we're not gonna launch directly the file, we're gonna install it, so I just need a main function. Okay, let's create a node. Let's name it turtle controller node, which inherits from node, and then def init self. We will need to call super dot init, and let's give it a name turtle controller. Okay, let's keep things simple. And then maybe do self.get logger with info turtle controller has been started. Okay, now let's complete the main. Node is equal to turtle controller node, and then rclpy dot spin with the node, and that's it for the initialization. Actually, we can also, so let's save and let's install it directly. So we add a comma here, and then turtle controller is equal to my robot controller dot turtle controller with a colon and main, and let's save it. Okay, now let's go back to the terminal. Let's go back to our ROS2 workspace and let's do callcon build -- symlink install. Good. Now let's do source bash rc and ROS2 run to see if we correctly initialize the node with turtle controller, and yes, we can find it. Turtle controller has been started. Now the node is spinning. Control C to quit. All right. And let's now start the control of the turtle. So we will need to create a publisher to the command velocity topic, and we will need to create a subscriber to the pause topic. And actually, how we are going to manage things is that we are not going to, so let's see what we did in draw cycle. In draw cycle, if you remember, we created a publisher to the command velocity topic, and then with a timer that was running here every 0.5 seconds, we were publishing some velocity. But we are not going to create a timer here. What we are going to do is we are going to create a subscriber to the pause topic, and in the subscriber callback, we are going to publish actually to the command velocity. Okay, so whenever we receive a pause, we publish a new comment. So let's start actually with the subscriber, and we are going to create a subscriber. So we actually already know what we need to do here. I'm going to go back to the terminal to find the name and the type. You can see the name is turtle1 pause and the type is turtle sim pause. So let's do from turtle sim.msg import pause, and then let's create a pause subscriber is equal to self create subscription, and the type is going to be pause. Actually, let's go back to a new line here, and then the name is going to be, let's just use the same name exactly. Okay, turtle1 pause, and then we need a callback. So let's create def pause callback with self, because we're in a class, and then pause. So we could put MSG, but I can also put pause, the same, with colon and then pause, so that we say that this is a pause data type, which is going to help for the auto-completion. For now, let's just use pass. Okay, let's keep the function empty and let's put it there. So self pause callback, and then 10 for the queue size. All right, so self create subscription, message type, the topic name, the callback, and then queue size. And just like this, the subscriber should work because, well, we have a subscriber, a callback, and we are spinning the node. Now, let's create the publisher. So I'm going to create a publisher here before the subscriber, self. So command vel publisher is equal to self.create publisher. What message do we need? So let's actually go back to draw cycle where we actually did the same thing. We need a twist message from geometry messages, and the name of the topic is turtle1 command velocity. So let's do that from geometry messages.msg import twist. I'm going to put twist here. Twist. Actually, let's also go back to a new line for readability. The topic name is turtle1 comment velocity, written like this. And then let's put 10 as the queue size. Good. So we have created a publisher and a subscriber. Now, what do we need to do? We need to publish something new when we receive a pose. So here we will need to check actually what is the current pose of the turtle, and depending on the pose, we may send different comments. But just to try and to make sure that we are actually sending some comments when we receive a pose, let's just send a very basic and stupid comment to the turtle just to check that our code is working and that the callback is working, okay? Step by step. When we are sure that this is working, then we can think about what's the best way to control the robot, okay? So let's actually create a comment. So I'm gonna use comment is equal to twist. Okay, we receive a pose here, and we're gonna create a comment that is actually a twist, all right? And now in the twist, what do we have? So let's do comment dot. We have angular and we have linear. So for this first step, let's say that we just want to make the turtle go forward. Even if it hits the wall or the edge of the window, that's okay. We just want to make it go forward. So I'm gonna do command linear dot x is equal to, and let's use 5.0 as a velocity, and then command dot angular dot z is equal to 0.0. I'm gonna leave the other one to 0, so no y and z linear and no x and y angular, okay? I'm just gonna focus on the x linear and the z angular, like I explained before when we did the draw cycle node. So we have a twist comment. Now I can do self dot comment vel publisher dot publish with the comment. Okay, so here we don't use the pose yet, but we just publish when we actually receive a pose, so in the subscriber callback. Okay, so this should be okay. Let's save the file and let's go back to the terminal. I'm gonna move it like this. Okay, clear. Let's actually do cd and source the bash rc. So I don't need to build anymore because I've used symlink install. Let's just make sure that we source the bash rc. And okay, in this terminal, let's do ROS2 run turtle sim node. Okay, we have the turtle right there, and in that one, let's run the controller. So ROS2 run my robot controller turtle controller. And now let's look very closely at what's gonna happen to the turtle here. I press enter, and okay, the turtle is moving forward and then hitting the wall. Okay, and you can see I hit the wall, etc. So the thing is that it's working. It is doing exactly what we wanted to do, which is that when we receive a pose, so here with the pose callback, we send a command to go forward. So that's exactly what the turtle is doing. And that's already a good progress in this application. So now what we want to do is we want, of course, to not make the turtle hit the wall, but to actually, let's say, to turn around when it gets closer to the wall and then come back and continue and just continue to move indefinitely. And so to do that, we will need to know what are the coordinates. And so I'm going to show you very quickly what are the coordinates. So let's just kill everything. Let's start the turtle sim again. And here I'm going to start the teleop. So ROS2 run turtle sim turtle teleop key, so that I can move the turtle. And when we move the turtle, we also want to know what are the coordinates of the turtle. And so to get the coordinates, well, here let's do clear and let's do ROS2 topic list. We have the pose that we can subscribe to. And in the pose, you have the X and the Y. But also, if you remember, what did we do before? We did a pose subscriber. And in this pose subscriber node, we actually filter the pose to just bring the X and the Y coordinates, which is basically what we want to know right now. So I'm gonna use this instead, ROS2 run my robot controller with pause subscriber. Good. And you can see we have so the X here and the Y. And so what you can see is that the turtle is now in the middle at about 5.5 and 5.5. So 5.5 on the X-axis, 5.5 on the Y-axis. Now let's move the turtle. So let's make it go forward and hit the wall. You can see now we are at 11, so just about 11 on the X-axis. And we are still at 5.5 on the Y-axis. Okay, so let's go to the upper right part. Okay, we are at 11 and 11. And let's go to the other diagonal. Okay, so let's go to the bottom right. Let's focus here. Okay. And we should reach 0 and 0. Yes, okay. So you can see, I'm gonna stop this one. You can see that in this window, we start at 0, 0 here. And then on the X-axis, we go until 11. On the Y-axis, we go until 11. So we know what are the coordinates that the turtle can reach. And so what we could say now is that if the turtle is close to the border, let's say by 2, so if the turtle reaches, for example, X, which is 9 or more, then it should turn around. Then we can do the same with Y is more than 9. We could do the same with X is lower than 2. And we could also do the same with Y is lower than 2. So we can make sure that we actually kind of draw the square inside the square. This is gonna be the safe square where the turtle can just move forward. And when the turtle goes outside of this, which is closer to the actual border of the window, then we make the turtle turn around. Okay, so again, let's do step by step. Let's actually start the turtle sim and let's imagine the current scenario. So the turtle is going forward. Okay, and let's just make it turn when it reaches this wall on the right. And that's it. All right, so let's stop this and let's stop that and clear everything. And let's go back to the code. So we are going to improve this pause callback. And here we will need to use actually the pause. Okay, we will need to use the current position of the turtle. So what I could do here is to check that if pose dot x, okay, we have the x coordinate is greater than 9. So greater or equal, it doesn't really matter here. So if the x coordinate is greater than 9, what do? We make the turtle move in a circular way. Maybe let's actually create the command first and then check this. So let's do command dot linear and let's also make the turtle go slower. So I'm gonna use linear x is 1.0 and then command dot angular dot z is equal to 0.9. So why those values? Well, those are values that I've tried before actually and that I know are working. So if you want, you can just start with those values and then increase a bit the x or z velocity or decrease them, all right, to find something that works. But by doing this, you can see here we move at 5. So the speed is 5 for the x linear. Here the speed is 1, so it's gonna go slower and it's also going to turn on the z axis. And so if the pose is greater than 9, we do this, but then we need to do also else, and I'm gonna put this in the else. So we only go forward if the pose, so if the x pose is not greater than 9. All right, so we have two different commands depending on the current pose. And then we, of course, publish the command. So let's save this and let's see what we have. Source -rc here. Let's run the turtle sim and let's run our controller. So not post subscriber, but turtle controller. Okay, good. You can see it's turning and then it's going again, and of course it's gonna hit the wall because we haven't specified what to do if the x is lower than 2. So as you can see here, the turtle was going forward because the x is lower than 9. When x reaches 9, we change the command. So instead of going to 5 speed on the x-axis, we go to 1, and then we also add an angular velocity. So the turtle is going to turn until, well, actually until the x pose is lower than 9, and in that case, we just continue to go forward. So now what we need to do is we need to handle the case for the left part, for the top part, and for the bottom part. And that's gonna be actually quite easy. So we can say if the pose is greater than 9, or the pose x is lower than 2, or the pose y is greater than 9, or the pose y is lower than 2. And that's it. Okay, so if we do this if, we check that actually the turtle is close to the wall. Okay, so either the x or the y is lower than 2, or the x or the y is greater than 9. In this case, we make the turtle rotate. Otherwise, we just continue to go straight. Let's save this. Go back here. Let's kill this one. Source-rc. Let's start the turtle sim node again. And the controller again. And let's see what's going to happen. Okay, we turn here and then go straight. And then we turn. And then go out of this, let's turn, and you can see it's turning again. So here it's hitting the wall a bit, but that's okay. Okay, and we turn again, etc. So for example here, I'm gonna stop the controller, and you can see when I stop the controller, well, the turtle just stops moving. So you can see here we hit the wall, and if you want to avoid that, you may want to actually increase the angular z velocity here. But if you do so, for example, I'm gonna do 1.5, okay, and let's see what's happening. So let's start the turtle sim, and then I'm gonna source the /rc and do the turtle controller. Okay. What may happen is that the turtle at some point, so let's wait a bit. Okay, you can see this behavior is that the turtle is actually gonna be stuck, because if it turns too fast, it may stay over the limit, and the limit here is y9, so the turtle is over the limit and is stuck. So that's why I have actually reduced the angular z to 0.9, because that's a value I found that works. You could go down even to, for example, 0.8 or 0.7, and that's okay. Even if the turtle hits the wall at some point, that's really not a problem. Okay, we are experimenting with ROS2 here. That's just a simulation. All right, so let's run it again, actually. So let's kill this and then do source-rc, run the controller. So we can start to run the controller actually before the turtle sim node. It doesn't matter, because it's only gonna wait for the pause and then send some comment. So nothing's gonna happen until we start the turtle sim node. So let's wait, I'm gonna wait maybe 1 minute and show you what it's gonna do. Well, and as you can see, the turtle is continuously moving and turning when it reaches the edges. All right, so everything is working correctly. And let's just run RQT graph to finish here. And now we can remove dead sinks and leave topics, and you can see we have our closed loop control. So we have the turtle sim here and the turtle controller node, and you can see the turtle controller is listening to the pose and then sending data to the command velocity. So we have a closed loop control here. Alright, that's the end of this episode. If you found it useful, you will definitely like my full course on ROS2 for beginners. This course contains more than 10 hours of content and will teach you everything you need to create complete ROS2 applications. You can find the link in the description. Thank you for watching, see you in the course or in the next tutorial of the series.